Hello, am I audible now?
Yes, ma'am.
Okay, so I'll start it once again. The screen is visible to you all?
Yes, ma'am.
Yes, ma'am.
Okay, okay. So I'll start off again. Uh, so initially we had discussed about the three factors which were CIA. The CIA triad talks about confidentiality, integrity, and availability. So here, in case of denial of service, the availability factor is targeted into a network. Now, what happens in case of an availability factor is, let's say you have a system where there is a server and a client. Now, we normally believe that in any attack scenario, there would be an intruder present into the network and he would be eavesdropping into the network and finding out what communication is happening between the server and the client. And probably he would capture the packets which are being flown from either the server end or from the client end. However, there can be one more case where the users which are present are existing into the network, they are communicating or they are sending in the request to the server. Now, wherever a request is being sent to the server, the request would be satisfied once the confidentiality and the authorization is satisfied. So, confidentiality, authentication, authorization, all of these are done at a later stage. The initial thing comes up with the availability factor. So, when the client is sending the request to the server, if the server itself is not able to receive the request, then the other factors like C and authorization and authentication will not come into the context. So, when there needs to be communication between the legitimate user and the server, and both of these are working in a efficient manner, but there exists certain situation where the legitimate user's requests are not being processed by the server, even if the user has proper credentials. The request packets are either not delivered at the server end, or 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 there can be a case where the server is not able to process the received request. Okay, that situation normally arises into a case where it is referred as denial of service. So what happens in a denial of service? You are restricting a user who is a legitimate user or a legitimate resource from being accessed. Okay, so normally in case of a denial of service attack, what happens? The target is the network resources. So your network resources can either be the bandwidth, you're targeting the bandwidth, you're reducing the bandwidth, or what you're doing, whatever bandwidth which is available into the network, the entire bandwidth is being consumed in either of the possible ways, so that the users who are legitimate users cannot send in their packets to the server, and when they'll not be sent to the server, there are other ways how would the request packets be sent, but still they are not delivered at the server end. So in turn, these are not satisfied by the server, even if the server is up. Okay, so here we are saying that in a denial of service attack, the attack is majorly on the availability of the network resources. Even if the server is up, even if the legitimate user has the right to access the server, still due to certain mechanisms which are present into the network, the request of the legitimate user is not satisfied and is not given a proper response. Okay, now here it says that the denial of service attacks can be initiated in many ways. The first one is transmission failure, second is traffic redirection. Further, you have DNS attacks and connection flooding. Okay, let's talk about the first point, which is transmission failure. Now, normally, when does a transmission failure occur? Anybody? When does a transmission failure occurs? Ujjwal,
जी मैम।
कब होता है ट्रांसमिशन फेलियर?
जब कोई अटैक हो, मतलब नेटवर्क में कोई सिक्योरिटी सही से ना हो।
What do you mean by transmission failure? Attack is leading to transmission failure. But what is transmission failure? Anybody else? Okay, that is referred as transmission failure. The packets which are being sent are not delivered. Okay, when such case arise, what are the possible cases where when will the packets not be delivered at the end?
Sometimes congestion will be there, so ma'am packets will be dropped.
Yes. So due to congestion, there are higher chances that the packets which are being transmitted from either of the ends, these gets dropped. Okay. The other thing which is traffic redirection. So traffic redirection normally means that you're sending the packets from client to the server. Now due to certain mechanisms which is present in between both of these ends, जो पैकेट्स आप क्लाइंट से भेज रहे थे, these are not delivered at the server end. These are either delivered at some other client, or it can be the other way. The client is sending the packets to some other destination. Instead, these are being sent to the server. That happens and leads to a denial of service attack. Okay, DNS attack and connection flooding we'll talk about in later stage. So as of now, what are we saying that we can initiate any DOS attack or any attack which is of type denial of service by doing any operations which is targeting the network, okay, or the bandwidth of the network. Okay, now there are cases like connection flooding. So what happens? This is one type of a denial of service attack. Here, see, this is a malicious party and this is a server. Okay, so first thing is this can be any system. Okay, it need not be a dedicated intruder. You can have a normal client as well who is sending the packets or the requests to the server. Okay, so let's assume that this is a client. Now, this client is sending the request to the server. There can be two cases. First case, when client and server both are present on same network, or we can say that the client is registered into the network where server is present. Okay, even if he is present in the same network or he is present outside the network, both of the clients will have a proper authentication mechanism so that server can process these requests. Okay, now first case what I assumed is that the client is present on the same network. Okay, now if the client is present on the same network, if I assume that this is a traditional setup where normal communication should happen, your client would send the request packets to the server. Let's say he had sent only one packet initially. Okay, now when he has sent only one packet initially, or uh, two, three packets initially, all of these packets which have been received at the server side will be within the connection capacity of the server. Okay, once these are satisfied, the response would also be generated depending upon the connection capacity or depending upon the bandwidth of the network between the client and the server. Okay, So there would be proper inflow and outflow of request and the response packets. This was a normal setup. The setup where the client behaves as an intruder. So for the client to behave as an intruder or for any other user to behave as an intruder, what he needs to do, since we were talking about the fact that we are consuming the entire bandwidth which is available across the server, we would send multiple amount of request packets so that the entire bandwidth which is available by the server is consumed by all of the request packets. In that case, what would happen? Even if the server has processed the request, he has found out that the request is from the genuine user, he will not be able to send in the response to the user. Why? Because the available bandwidth has been completely utilized by the request packets. The user sends in the request packets within no time so that there isn't any empty slot available for the server to send in the response for the client. Okay, in that case, what would happen? The server would majorly be involved in processing the requests with packets which is received, thereby exhausting the resources available at the server end. Okay, you are exhausting the number of connections which the server can have between the client, and in this way there are higher chances that the server goes down by processing only the request packets. Okay, the outcome is the server goes down or you are not sending the response packets to the user. Okay, once you're not sending the response packets to the user, you are preventing the users to access these services. You are denying the users to access the valid services. Okay, this is done by flooding the entire connection or the communication channel by sending n number of request packets or by exhausting the number of communications which the server can have. Clear? Any doubt? Okay, moving ahead, the entire DOS is based upon flooding the network, not making the server sending a response to the legitimate client. Okay, now this entire connection flooding can happen with multiple packets. How multiple packets? The malicious party or the normal user who is sending in the request. So these would be some dedicated packets whose information the user is requesting or based upon what he is trying to establish the connection between the server and client. So based upon the packets which are flown between the client to and the server, there are multiple types of connection flooding attacks or denial of service attacks based upon connection flooding. These are the types of connection flooding attacks. First is eco Kagel, ping of death, Smurf attack, sin flood, and teardrop. Okay, we'll go ahead with each of these attacks one by one. Let's go ahead with the basic one, which is ping of death first. Okay, so okay, so why do we send ping command? We send ping command to identify whether a client is present into the network or not. Clear?
Yes, ma'am.
What packets are sent when you're sending ping? Which protocol is ping related to?
Some ACK packets.
ACK packets. ICMP. ICMP packets are sent when a ping pack request is sent. Okay, so when you're sending ping, you're sending the IP addresses as well associated with ping. Okay, now here in the figure, what is done is there's a malicious party. He can be into your network, he can be outside your network. Okay, he can be a valid client, he can be a non-legitimate client as well. It doesn't matter, whatever it is. Okay, so the ping of death attack can either be done by intruder or by the legitimate user, or any sort of attack in case of DOS can be done by the intruder and by the legitimate user. Okay, here we are assuming that as of now it is just a malicious party. Okay, now when we are sending the request from the malicious party, what we have to do? We have to completely utilize the available bandwidth with the server. So whatever request, n number of ping requests, had it been that only these requests were initially sent as ping request, depending upon the available capacity, the responses or the replies were also generated. So you had sent ICMP request packets over here, and ICMP response packets are received at the client end in the form of ping replies. Okay. Now, in case of a denial of service attack, what would happen? The number of ping requests which are originated from the malicious party would be larger, so that the available bandwidth by the server is consumed by all of the ping requests, and there isn't any free communication link, so that the server can send in the reply package to the destination. Okay, here the number of pings requests which are sent are larger in amount than the number of ping replies received at the destination. Or there can be case that there are multiple ping requests whose responses are not at all received at the client's end. In this case, what would happen? The server would majorly involve its time in processing the received requests at certain instance of time. The window which is present at the server side, or the resources which are present at the server side, will majorly be involved in processing the received requests, thereby leading to a situation where your server turns down and terminating the connection between the client and server, so that you are not able to satisfy the legitimate request of the clients or legitimate request of the legitimate client. So even if there is a client who actually wants to identify the response of a ping, that client's request would either not be delivered at the server end, or once it is delivered at the server end, the response will not be generated within specific time. The outcome is that you are not granting the request, or you're not granting the response to the legitimate user for whom the actual server is built up, or for whom the actual authentication system has been built up. Clear? Here you are consuming the network resources, you are consuming system resources, or you are consuming operating system resources. You are also consuming bandwidth of the server. Finally, the outcome would be the server is down, the legitimate user's request is not satisfied. Okay, moving further with the other type of attack, which is Smurf attack. Okay, now in case of Smurf attack, please see over here, there are two clients. One of the client is malicious party and the other one is network. Okay, so here this ring denotes the number of clients which are connected to it. Okay, now in a Smurf attack, what happens is normally the packets which are sent to the targeted server are ping packets only or the ICMP packets only. In the previous case, the ping packets were generated from only one client. Okay, here what is being done, the ping request is actually being generated from a malicious party, but it is assumed that the pings are actually generated from the clients which are connected over here. Okay, how is it being sent? The packet which is being sent from malicious party to this end is an ICMP packet, okay, or a ping packet. Now when you are sending the ping packet, what do you send? You send the IP address also along with that particular ping. Okay, what if the IP address which is being sent is the spoofed IP address? Clear? If the IP address is a spoofed IP address, the reply which would be generated to that spoofed address. Clear? What is the malicious party doing over here? He is sending the ping request packet to the clients which are connected in this network. Now, when the response would be generated, the response should actually be generated to this malicious party, but instead the response is generated to the target server. Why is it so? When the malicious party had sent in the ping request, he had sent in the request with a spoofed IP address of the originator. Okay, so when the replies would be generated, the replies would be generated to the originator itself. Clear? When the malicious party had sent in the request, he had added the IP address of the target server in the originator. That is why when the response of the ping was generated, it was generated for target server. Okay, the target server did not send any request packets. The request packets were sent by the malicious party. Those request packets were sent in larger amount, or they were sent to in only a single packet was sent to this particular network, and all of these hosts which are present into the network received it. Once the response would be generated by the clients which are connected into the network, since these are larger in number, the response would also be larger, and therefore the ping replies which are generated, these ping replies are generated and received at the target server. In this duration, when a legitimate user tries to connect with the target server, he will not be granted access because the capacity or the network capacity available by the server is as of now utilized by the ping replies which are being sent from this network to the target server, thereby preempting the or prohibiting the legitimate user to access the resources at the server side. And finally, you are restricting the user to access the target server. Also, your target server is busy in processing those replies which are not dedicated, which were not even originated, whose request was not originated from its end. Clear? Any doubt in Smurf attack? Can you tell me any defense for Smurf attack? How can you prevent Smurf attack in such case? Or in general, if I ask, can anybody tell me one defense which can be used in denial of service attacks? Harshit,
Yes, ma'am.
can you tell me any defense for DOS? Bibhas?
Yes, ma'am.
Hmm. Defense.
And we can use firewalls to prevent this
How
kind of
would
attack.
firewall help in preventing DOS? Tanvi,
Yes, ma'am.
any answer? What is happening in connection flooding? How many target machines are you having? Anybody? Anybody please answer. How many target machines are here?
One.
Single target machine. And which one is the attacker machine? How many attacker machines are there?
It can be many.
Many.
As of now, what do we have? We are only having one. Now,
One.
that happens in different cases. This is, in denial of service, you are only having one client. Okay, the other case which you are talking about is distributed denial. Okay, so in a DOS, you have one client and one attacker and the one target machine. Fine. In connection flooding, what is happening? You're sending multiple packets to the server. So I'm sending multiple ICMP packets or I'm sending multiple random UDP packets to the server. Okay. So you are having only one host and of the system which is satisfying that host request. Okay. So can you have a mechanism so that you limit the connections between both of these clients?
Ma'am, can we do three-way handshaking method?
See, that would happen in different cases. Here, if I talk about normal general DOS attack, okay,
मैम
here,
हैविंग फायरवॉल तो वहाँ पे हम लोग के पास ऑप्शन होता है ना कि वी कैन ब्लॉक द आईपी एड्रेस फ्रॉम द ओरिजिनेटिंग.
तो आप तो एक ही क्लाइंट को completely ब्लॉक कर दिए.
मैम तो
फिर
स्पैम
मैंने
फिल्टरिंग जैसे होता है ना कि ये आईपी एड्रेसेस रिस्की हैं या मेलिशियस ट्रांसफर डेटा कर सकते हैं, तो हम लोग उस पे उस पूरे क्या कहते हैं क्या
What
आईपी
did I
एड्रेस
say?
के.
I said DOS can happen from legitimate as well as non-legitimate. So in this case, what are you doing? If you block a particular IP address, even if that client is legitimate, then you will not be able to establish the connection. So the mechanism can be that you limit the number of connections between the clients. अगर मैंने बोला होता कि सिर्फ 5 ही ICMP पैकेज या फिर 5 ही पैकेज जा सकते हैं malicious पार्टी से टारगेट सर्वर तक या फिर किसी क्लाइंट से टारगेट सर्वर तक, 5 से ज्यादा करूंगी तो ऑब्वियसली नेटवर्क कैपेसिटी एग्जॉस्ट हो जाएगा मेरा, या फिर कनेक्शन कैपेसिटी एग्जॉस्ट हो गया. जब तक वो 5 until those 5 request packets do not get the response, I will not establish a newer communication link between the client and the server. In this case, you have ample amount of network capacity so that your legitimate users can send in the requests. Clear? Acceptable?
Yes, ma'am.
Any doubt in the solution?
Ma'am, but ma'am, one client will can send many requests, no?
Yeah, but you'll have
Then
to limit the connection. Na? That thing, see, when we talk about TCP, this would come in later stage. I'll explain you initially. When we talk about TCP, so there is a connection window at the server side. It will not happen that with all of the clients you can establish hundreds of connections. You will have a limit. You'll always have a TCP window size at the server's end, which will tell you that how many connections can a particular client establish. That three-way thing which somebody told you, that can also cause a DOS attack. Okay, so one proper solution is that if you limit the number of connections, yes, there can be multiple connections between the client and the server. But if you go with that fact, you can have a situation which leads you to DOS attack. In order to prevent that DOS attack, we are trying to have certain defenses that I limit the number of connections.
okay.
Clear?
Yes, ma'am.
Okay, so moving ahead, it comes as SYN flood. So the thing which somebody was telling about TCP. So a normal TCP connection happens that you are sending the sync message. When the sync message is received at the server side, the SYN value is stored in that TCP window and an acknowledgement is sent to the user. So both of these numbers are stored at the server side. Okay. When the received message at the user end matches with the SYN value of the sent request, he would send the acknowledgement to the server. Okay. So what is happening? Once the matching in the values of SYN and acknowledgement happen, then the entire connection is established and you can send in the data from either of the ends. Okay. This situation can also be used to launch a DOS attack. Such type of DOS attack or the connection flooding attack over here is referred as SYN flood attack. Okay. How can you have? My connection will only be established once the acknowledgement is received at the server side. If the acknowledgement is not received at the server side, your connections will not be completely established. Okay. So only the first two packets are sent and the last packet is not sent. Such connections are referred as partially open connections at the server side. ओके तो जिन कनेक्शंस का एक्नॉलेजमेंट नहीं मिला वो कंप्लीटली कनेक्शंस नहीं हुए, कंप्लीट कनेक्शंस नहीं हुए. नाउ इफ आई वांट टू यूटिलाइज दिस थिंग to establish or to launch a DOS attack, what can I do? Your malicious party can send multiple SYN packets at the server, okay, so that the entire network bandwidth available with the server is utilized by the received SYN message, and there can be parallelly SYN acknowledgement message sent to the malicious party. Since only these two messages flow between malicious party and the target server, and the entire available bandwidth is utilized by both of these packets, your malicious party works in two cases. Either he is not sending the acknowledgement, which is very intentional and it can happen. The third case is there isn't any network bandwidth available to send the acknowledgement packets to the server. Okay, such cases would further lead to partially open connections. No new communications or no new packets can be received at the server side, even if the packets are there from a legitimate client who is present within the network or who is present outside the network. Therefore, this would lead to link terminations between the client and server, or between the malicious party and server, and also the collapse of target server. Okay, now if I try to have defense for this, I can say that I'll have 5 of the TCP connections, or I'll have a window size of 5 for connections between a client and the server. If I second case is, if I try to have one more layer of defense, I would say that if a particular connection is partially open for, let's say, 10 minutes, that is, if the malicious party over here is not sending the acknowledgement packet to the target server, what can target server do? He can terminate the connection, or he'll remove. How would he terminate the connection? He'll remove the entry of that sync message and the sync and acknowledgement message from its window. That can also be a new defense. So I have 5 connections which can be established between a malicious party, or not malicious party, I'll say between a client and the target server. If those 5 window size is occupied, I'll no more have any connection request from that particular client. Also, I will not use the existing connection until an acknowledgement is received within 10 minutes or 15 minutes, whatever time you want. If it is not, then I'll remove that particular entry, allow a newer communication or allow a newer connection to come in. Clear? Any doubt? Server, at server end, network administrator. Okay. Next is teardrop attack. So for today, this is the last one. Now, whenever any message has to be sent between the client and server, we said that we would majorly address the or look into the network capacity. If the message which needs to be sent is of larger size, what is done? The message is divided into fragments, or here it is, message segments are created. Clear? Now, when the message segments are created, it is not necessary that every time the segment who has been created first will be received first at the server end. There can be congestion into the network. Some packets might get delayed, some packet might arrive in no time. So what is being done? In the fragments of the message which is created, there is a sequence number associated to these messages. So over here it is given that 1, 2, 3, 4, 5, 6 and 7, 8, 9 is the sequence number which is given to the message segments. Now, depending upon the congestion or delay, whatever is there into the network, your server has received the message and once it has received the message, he would want to generate the actual message. So in that case, the assembly of the message would be done. So depending upon the sequence number, it would arrange the entire segments. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the message which is received is a valid message since all of the sequence numbers are present, and these have been arranged and generate a meaningful message at the server side. So this is a case which happens in a traditional setup. Had this being done to an environment where an intruder is present, so when these message segments are created, within the communication or within the transmission channel, had there been a case that the intruder is present into the network, he's eavesdropping, okay? So the malicious party, what has done, he has changed the sequence numbers of these packets, okay? Now when the sequence number are changed and when the packets are received at the server side, now as seen it is here that there are two packets which are of sequence number 3, two packets which are of sequence number 5. Your server would now be busy in finding out which one is the correct packet so that the actual message can be generated. The entire resources which are present at the server would be busy in finding out which is the valid packet, thereby making the server busy in such useless work, not allowing the server to address the problems of the legitimate user and denying the resources to the legitimate user and wasting the resources in assembling the message, leading to failure of the target system. Clear? Any doubt? Can anybody tell me defense for teardrop attack? If not, read it. Okay, yes. Yes, you can have, but it would not be effective. Because again, there can be cases that the intruder modifies it. Hmm? Think we'll discuss it in next class. Okay, so tomorrow you have a minor exam. So everybody please be available on 12. I'll upload the questions. You would have to write it in your hard copies, and at around 1 o'clock itself, you'll have to submit it.
Ma'am,
Okay?
can you please
I
again tell the syllabus of
deliver everything what has been taught till now. Network management, initial basics, then SNMP V1, V2, whatever is there in your slides, and SNMP V3, the document which I had sent to you. Then you have DAC, MAC, RBAC, the security goals document which has been sent to you.
thank you.
Ma'am, yours will also come today's class.
What?
Ma'am, today's
If you
class.
want, I can do it.
No, ma'am.
Okay, fine. So please be available. Okay.
Yes, ma'am.
Fine. Tomorrow you'll
Thank
be
you.
tomorrow you have a lab as well, right? From 10 to 11.
Yes, ma'am.
Yes, ma'am.
Okay, fine.
Thank you, ma'am.